Hello everyone, good morning. This is lecture number 13 of analytical geometry. So if you haven't watched all the previous classes, to go through all the previous classes, right? And tomorrow we have a first test on analytical geometry, uh, which consists of the topics DC, direction cosine, direction ratio, planes and straight lines, right? So these four topics you're going to have the first test. The Telegram group, I have mentioned you how to write the test, right? So if you haven't joined Telegram group, join Telegram group. So all the updates regarding tests will be on Telegram group only, right? So if you haven't joined, join that group. Link is in description. Okay, in the last two class, we have been seeing spheres, right? We have been seeing spheres. So in this class also, we're going to continue spheres. So if you haven't watched all the previous classes, go through all the previous classes, right? Okay. Okay, so we'll start. So actually, before getting into today's class, I just want to recall the previous class, right? In the previous class, in the last part, we have introduced a new concept. Based on that, we have solved one problem, right? So I'll just show you the notes of the previous class. We have introduced this topic, plane section of a sphere. So in this topic, we are going to do almost 10 problems in this class. Uh, we have already did one problem in this topic, so we're going to continue doing problem based on this topic. We have already solved one problem. In this class, we'll be solving another 9 to 10 problems in this class. All problems are very important. So before that, we will just recall this concept, right? Very important concept. Based on this only, we're going to solve this problem. This is a last class notes, right? So first is based on this three note only, we're going to do problems. This is the second topic in sphere. The first topic in sphere is based on the general form, center, radius, and this is the second topic in sphere, which is plane section of a sphere. So we have a sphere. If you section, right, if you cut it by a plane, the result will be a circle, right? You can see we have a sphere. So if you cut it by a plane, so you just take that circle sphere. Sorry, you have a sphere. You cut it by a plane, right? Cut it by a plane. The result will be now a circle, right? So what is the equation of circle in 3D form? So whenever you have a sphere combined with a plane, that will be a circle. This is what I have said in the previous class, right? Previous class is very important. What is the equation of circle? Whenever you have a sphere and a plane, that represents a circle. Whenever you have a sphere and a plane, so sphere, a plane, we are sectioning by a plane, the result will be a circle. Our aim is to find the center and radius of this circle. This is what our main problem will be. So they will give a sphere, they will give a plane. The result will be a circle. So this red one is a circle. What is the center? So this C1 is the center of circle and R is the radius of circle. Our aim is to find the center and radius of the circle. How the circle is formed? It is formed by sectioning a sphere by a plane. So that is what we discussed in the previous class, how to find the center of circle and how to find radius of circle. Now let capital C and capital R be the center and radius of sphere, because they will give a sphere and a plane. So from that sphere, you can find the center and radius using the known formulas. So this capital C is the center of sphere and capital R is the radius of sphere. See, small r is very easy to find. Small r is the center of, sorry, radius of circle, right? So you just call this distance to be equal to p. Now what is p? P is nothing but the perpendicular distance from this point to the plane. Yes or no? This p is nothing but the perpendicular distance from the point C to the plane. So you can easily find p using the distance perpendicular distance formula, because you already know the center of sphere and radius of sphere, that you can easily find from the question itself, right? After that, you can easily find p. So p you can easily find, r you can easily find. Now to find small r, you can apply Pythagoras theorem. P square plus r square is capital R square. From that, you can find radius of circle. How to find center of circle? How to find center of circle? That is what we discussed in the previous class. What we discussed is, so find the center and radius of the circle. So whenever they give circle means they will give a sphere and a plane, right? So they have given the sphere and they have given the plane. So we need to find the center and the radius of this circle. How to find center and radius means, see, first they have given the sphere. So find the center and radius. So center turns out to be 4 minus 2, 4. Radius turns out to be 9. Right? So center and radius we can easily find with the help of the given sphere. Our aim is to find the C1 coordinate because C1 is the center of the circle. So how to find C1? You can see I'm writing the equation of CC1. This CC1 is a straight line, right? CC1 is a straight line. What is the equation of straight line in symmetrical form? X minus x1 by A is equal to y minus y1 by B is equal to z minus z1 by C. Where x1, y1, z1 is any point on the line and ABC is the direction ratio of the line. So I'm writing the equation of CC1. So we already know one point coordinate 4 minus 2 and minus 4, but we don't know the direction ratio of this line. So find the equation, write the equation of straight line in symmetrical form. So for this line I know one point which is 4 minus 2, 4. So equation of CC1 will be x minus 4 by A, y plus 2 by B, z plus 4 by C, but we don't know the direction ratio. Now how to find direction ratio is, see, we already know the equation of plane. Now what is the direction ratio of normal to the plane? It is 1 minus 2, 2. Right? Whenever you have a plane, this ABC denotes the direction ratio, right? AX plus BY plus CZ plus D is equal to 0 is the equation of plane where ABC is the direction ratio of normal to the plane. So we already know the normal direction ratio is 1 minus 2 and 2. So from this, these two lines are parallel. That means this direction ratio and this direction ratio are proportional. That we know, right? Two lines are parallel means A1 by A2 is equal to B1 by B2 is equal to C1 by C2, where A1, B1, C1 is the direction ratio of first line, A2, B2, C2 is the direction ratio of second line. Using this idea, so this direction ratio we don't know. I'm assuming this as A comma B comma C. This direction ratio is 1 minus 2, 2. So from this they are proportional. So A by 1, B by minus 2, C by 2. From this I can get the value of ABC, where ABC is the direction ratio of the straight line. Now I can easily find the equation of CC1. X minus 4 by 1, y plus 2 by minus 2, z plus 4 by 2. This is the equation of CC1. See, for equation of CC1 we know one point, but we don't know direction ratio of this line. For that, to find direction ratio of this line, I'm just drawing the normal direction ratio and these two are parallel. With the help of this, I'm finding the direction ratio of CC1. So after this, any point on this line will be of this form, right? So if I vary k, I can get all the points in the line. Now to find for what value of k, C1 takes that value. See, any point on the line will be of this form, right? Let's say equal to k. So x comma y comma z is, if I vary k, I can find all the points in the line. So for some k, C1 will take the value. Now you can see C1 lies in this plane. C1 lies in this plane. Using that idea, so this coordinate must lie in the plane. So if I substitute that, I'll get k to be equal to 1 by 3. So when k is 1 by 3, C1 takes this value. So that means 13 by 3, C1 coordinate is 13 by 3 minus 8 by 3 minus 10 by 3 is the center of the circle. Now radius is very easy. You can find radius in two ways. Now you know C1 also, you know C also. You can find P using the distance formula between the 2 points, or you can find the perpendicular distance from this point to the plane. For finding P, you can do in two ways. One is distance formula because you know C1 also, because C1 just now you have found. Using that you can find P, but I will always recommend you to find the value of this P using perpendicular distance formula. Now what is P? It is nothing but perpendicular distance from center of sphere to the plane. So just apply the formula ax1 plus by1 plus cz1 divided by root of a square plus b square plus c square. You will get P to be equal to 1. So you know P to be equal to 1, R to be equal to 9. So you need to find small r. You can apply Pythagoras theorem to get the value of small r. A very important problem. This is what we discussed in the previous class. That is uh, how to find the center and radius of a circle. That circle is formed by sectioning a sphere by a plane. Is it clear? Can you move on to the next problems? See, if you understand this single problem, then you can do any problem in this class. And the other important note is equation of sphere passing through a given circle. So whenever they say circle in 3D, you just remember the equation will be a sphere and a plane. Okay, I'm repeating this because it is very important. So don't whenever in the exam point of view, if they say find the equation of circle means you don't need to find you need to find a equation of sphere and a plane in 3D. Whenever you need to find an equation of circle, you need to find a sphere and a plane. Remember that, right? Now, second note is what is the equation of sphere passing through a given circle? So, whenever they say circle, that has to be a sphere sectioning by a plane. So, we will have a circle. Now, sorry, yes, we have a circle. Now, we need to find a sphere that passing through the circle, right? So they will give a circle. So they will give a circle means they will give an equation of sphere and a plane. That means it will form a circle. So you need to find a one more sphere that has to pass through this circle. So you can see it is passing through this circle. So what is the equation of this sphere? This sphere is nothing but s plus lambda p is equal to 0. So equation of sphere passing through a circle is given by very important. S plus lambda p is equal to 0. S plus lambda p is equal to 0. Okay, so we will do more problems based on this, right? So if you understand this single slide, every problem is easy to follow. This is what we discussed in the previous class. Now we will do more problems. So we will do one more problem based on finding the center and radius of a circle. We will do one more problem based on this. Problem to find the radius and center of circle. Find the center and the radius of circle. So they have given the equation of circle. X square plus y square plus z square is equal to ax plus by plus cz, comma, and x by a plus y by b plus z by c is equal to 1. So they have given the equation of circle. So whenever I say circle, they will give a sphere. They will give a sphere and a plane. So we need to find the center and radius of this circle. Just a minute. Okay, so they have given the sphere and a plane, right? Sphere and a plane. So they have given a sphere and we need to find the center and the radius of this circle. How the circle is formed? This is formed by sectioning a plane. So they have given the equation of sphere and the equation of plane. We need to find the center and radius of the sphere. Sorry, circle. Let us say this C1 is the center of circle and the small r is the radius of circle. Capital C is the radius of sphere and capital R is the radius of circle. Capital C is the center of the sphere. Capital R is the radius of sphere. So we need to find the C1 coordinate and this R, right? And we need to find the radius of circle. Okay. So first, they have given the equation of circle to be x square plus y square plus z square minus ax minus by minus cz is equal to 0. Now what is general form? So that means 2u is equal to minus a, 2b is equal to minus b, 2w is equal to minus c. So we have u to be minus a by 2, b to be minus b by 2, w to be minus c by 2. The center is minus u minus b minus w. So a by 2, b by 2, c by 2 is the center of sphere. Center of sphere. So this is a by 2, b by 2, c by 2. Now we will find capital R. Capital R is the radius of sphere, which is root of u square plus b square plus w square minus b. So root of u square is a square by 4, b square by 4, c square by 4, and d is 0. So we will have 1 by 2, 1 by 2 root of a square plus b square plus c square is the radius of sphere. 1 by 2 root of a square plus b square plus c square is the radius of sphere. So we need to find C1 coordinate and small r. So we will do one by one. Okay. Now, what is equation of CC1? So what is equation of CC1? So you can see this straight line is passing through this point. So that means a by 2, b by 2, c by 2 is one of the coordinate. A by 2, y minus b by 2, z minus c by 2. Let us say this capital ABC is the direction ratio because we already have small ABC there. Where capital ABC is the direction ratio of that straight line CC1. Now, what is the direction ratio of normal to the plane? So you can see this is the plane. What is the direction ratio of normal to the plane? They are given this plane, right? Now, what is the direction ratio of normal to the plane? So, given equation is ax plus by plus cz plus minus d. So, 1 by a, 1 by a, 1 by b, 1 by c is the direction ratio of this plane, right? Ax plus by plus cz plus d is equal to 0 means ABC is the direction ratio. So, direction ratio of normal to the plane. Direction ratio of normal to the plane is 1 by A, 1 by B, 1 by C. Now they are parallel. So they are parallel, right? They are parallel. So these two direction ratios are parallel. That means we have assumed that this has direction ratio capital ABC and this has direction ratio 1 by A, 1 by B, 1 by C. So that means we will have CC1 is parallel to direction ratio of normal to the plane. So that means the corresponding direction ratios are proportional. So A divided by 1 by B by 1 by B, C by 1 by C. That means A is 1 by A, B is 1 by B, C is 1 by C. This direction ratio only need not be unique. You can say all are equal to K. So K by A, K by B, K by C can also be direction ratio. I am putting K to be equal to 1 because it need not be unique. Okay. See, what is the equation of some sphere in general form? X square plus y square plus z square plus 2ux plus 2by plus 2wz plus d. There is no d term here. That is why I am putting d to be equal to 0. There is some constant term means you will equate that to d. X square plus y square plus z square plus 2ux plus 2by plus 2wz plus d is equal to 0. So there is no d term. Okay. So that means this is the direction ratio of This is the direction ratio of this straight line. So therefore, equation of equation of CC1 is x minus a by 2 divided by 1 by a, y minus b by 2 divided by 1 by b, z minus c by 2 divided by 1 by c. So any point on this line will be of the form x is equal to k by a plus a by 2, y is equal to k by b plus b by 2, z is equal to k by c plus c by 2. So for some k, c1 will take that value. So any point on this line will be of the form. If I vary k, I can get all the points in the coordinate, all the points in the line. So for some k, c1 will take the value. How to find that? For what values of k it takes c1 value. Now this point lies in the plane. This point lies on the plane. So what is the plane they have given? It is x by a plus y by b plus z by c is equal to 1. So this point lies in this plane. Now you substitute this x y z there, right? Substitute this x y z there and find the value of k. I'm not going to do that. So substitute this coordinate, right? Substitute x is equal to k plus a by 2. You will get k to be equal to, you will get k to be equal to minus a square b square c square divided by 2 times a square b square b square c square c square a square. This is what you will get k. So you just substitute k x y z value there, solve for a k. So if k takes this value, if k takes this value, that will be the c1 coordinate, right? So therefore c1 is given by, c1 is k plus a by 2, right? This is same as k plus a by 2, k plus, sorry, k by a plus a by 2, k by a plus a by 2, k by b plus b by 2, k by c plus c by 2. So when k takes this value, this is the center, right? You don't need to write this briefly. The center is this, where k is this, just write that is enough. Now you need to find the radius, right? This is the center point where k takes this value, where k is minus a square b square c square divided by 2 times a square b square plus b square c square plus c square d square, right? Okay. Now we need to find the radius of sphere. So radius of sphere, let us call this distance to be p. Let us call this distance to be p. This is P. So P is the perpendicular distance from this point to the plane. We can find that using a distance, perpendicular distance formula. We already know capital A, find small r by Pythagoras theorem. Okay. So P is the perpendicular distance from the center of sphere to the plane. What is the plane? It is x by a plus y by b plus z by c is equal to 1. So it is x1 by a, y1 by b, z1 by c minus 1 divided by root of 1 by a square, 1 by b square, 1 by c square. See, ax1 plus by1 plus cz1 plus d divided by root of a square, b square, c square. That abc is the direction ratio. So you just substitute x1, y1, z1 is center of sphere, which is a by 2, b by 2, c by 2. So instead of x1, you substitute a by 2, b by 2, c by 2. You will have this to be equal to Just a minute. So you will have this to be equal to ABC divided by 2 times root of a square b square plus b square c square plus c square a square. This is the value of p, and you use that p square plus small r square is capital R square, right? So p square plus r square is capital R square. So you already know p, you already know capital R. So find small r. So you will get radius to be equal to 1 by 2 root of a square plus b square, b square plus c square, c square plus a square divided by a square b square plus b square c. This is what you will have the radius to be equal to, right? It needs some simplifications, but the problem is easy. So this is how to find the center and the radius of a circle. That circle is formed by the circle is formed by sectioning a sphere by a plane. Find the equation of circle lying lying on the sphere lying on the sphere x square plus y square plus z square. See, for sphere, the coefficient of x square, y square, z square should always be equal to 1. X square, y square, z square minus 2x plus 4y minus 6z plus 3 is equal to 0, and having center at 2 comma 3 comma minus 4. See, very very easy problem. Just think about it how you can do. Saturday I will be uploading the question paper. Within Sunday evening you can submit, no problem. Within Sunday 6 p.m. you can submit the answer. So you just do this problem. We will have a 2 minutes break. Hello, hello, hello. Yes, anyone have idea how to do this problem? So there we need to find equation of circle. That means we need to find sphere and a plane. We already know sphere. Only thing is we need to find equation of plane. So find the equation of circle lying in the sphere and having center at this point. So very simple problem. So we need to find the equation of the sphere, right? We need to find the equation of this circle. This is cut by this plane. This is cut by this plane. So what is the equation of circle? It is nothing but a sphere and a plane. So this is the center of sphere. This is radius of sphere. This is center of circle. This is small r, radius of circle. This is radius of sphere, center of sphere, radius of circle. Okay. So we need to find the equation of this circle. Very easy. So equation of circle is nothing but a sphere combined with a plane. Sphere combined with a plane. Right? So we already know sphere. So we need to find the equation of this plane. That's it. We need to find the equation of this plane. That's it. So how to find the equation of this plane? How to find the equation of this plane? Okay, okay. They have given the center also. So find the equation of circle lying in the sphere having center at 2, 3, minus 4. So they have given the center also. Center is 2, 3, minus 4. So very simple. So we need to find the equation of this plane, right? So the required equation of the required equation of circle is given by S is equal to 0, P is equal to 0. We already know S. We need to find plane equation. Now equation of plane is to find equation of plane. Now we can see this plane is passing through this point 2, 3, minus 4. So it passing through 2, 3, minus 4. So what is the equation of plane passing through this point? A into x minus x1 plus b into y minus y1 plus c into z minus z1 is 0. So we will, where ABC is the direction ratio of normal to the plane. So A into x minus 2, B into x minus 3, C into x plus 4 is equal to 0, where ABC is direction ratio of normal to the plane. normal to the plane. Now, if I know the value of ABC, problem is over because we already know S is 0. S is, we already know S, we need to find P. So, if I find ABC, problem is over. Now, how to find ABC? How to find ABC? How to find ABC? Now, we can see what is the direction ratio of CC1. So, before that, we will find C, right? To find to find capital C. So capital C is the center of sphere. So what is the center of sphere? X square plus y square plus z square minus 2x plus 4y minus 6z plus 3 is equal to 0. So that means 2u is equal to minus v, 2v is equal to 4, 2w is equal to minus 6. So u is minus 1, v is 2, w is minus 3. So center is minus u minus v minus w. So that means we will have 1 comma minus 2 comma 3. So 1 comma minus 2 comma 3 is the center of sphere. 1 comma minus 2 comma 3 is the center of sphere. Now what is direction ratio of the line CC1? We need to find the direction ratio of normal to the plane. This is the direction ratio of normal to this plane. So for that, I'm finding direction ratio of CC1 and I'm using and I will be using the condition that they are parallel. Now what is direction ratio of line joining 2 point? X2 minus x1, y2 minus y1, z2 minus z1. Now what is direction ratio of CC1? Direction ratio of CC1 is nothing but x2 minus x1. So 2 minus 1. So 2, 3 minus 4. 2, 3 minus 4 minus 1 minus 2, 3. This is the direction ratio. Now, direction ratio of normal to the plane is parallel to the line CC1. So, what is direction ratio of normal to the plane? It is ABC. What is direction ratio of CC1? 1 minus 5, 7. So, they are parallel. So, we have A by 1, B by 5, C by minus 7. So, that means A is 1, B is 5, C is minus 7. Or you can also put equal to K also. But if you take K outside, um, it will be same only. So that means you have found ABC. Let's call this as equation number 1. So 1 becomes A into x minus 2, B into x minus 3, C into x plus 4 is 0. So A is 1, B is 5, minus 7 times x plus 4 is 0. So x plus 5y minus 7 is it? Minus 2 minus 15 minus 28 is 0. So you will have this is the required plane. Minus 17 minus 45 is equal. This is the equation of plane. So the equation of circle is S is equal to 0, P is equal to 0. So you just write S and P values. We already know equation of S. Now we have found equation of P. Is it clear? A sphere plus plane will be a circle. So whenever you are writing, you will have to write sphere comma plane. Just a minute. I'll have a 1 minute break. Actually, I'm not feeling well. So I will write down one more problem. You can work out that. You can do this problem now. Very easy problem. Just draw the diagram. You will have clarity. Just draw the diagram and try to do the problem. Yes, good. So center, radius you can find a perpendicular distance that will give you a radius. So you can easily find the equation of sphere. You can do this problem, right? Or I want to do. So find the equation of sphere whose center is at the point 1, 2, 3 and which touch the plane 3x plus 2y plus z plus 4 is equal to 0. Find also the radius of circle in which the sphere is cut by the plane x plus y plus z is equal to 0. Very simple problem. So find the equation of sphere. So we need to find the equation of sphere. So they have given the center and you can see it touching this plane. So it touching this plane. So we will have so it touching this plane, right? Right. So we need to find the equation of the sphere. The sphere is touching this plane. So that means radius is nothing but the perpendicular distance, right? So we have radius to be equal to this perpendicular distance. So they are already given center. So center is 1 comma 2 comma 3. So radius of the sphere is the perpendicular distance from that point to the plane. So first we will find the radius. So radius nothing but perpendicular distance from that point to the plane. So you will have 3x1 plus 2y1 plus z1 plus 4 divided by root of 9 plus 4 plus 1. So here x1, y1, z1 is 1 comma 2 comma 3. So 3 into 1, 2 into 2 plus 3 plus 4 divided by root 14. So 3 plus 3, 6, 6 plus 4 is 10, 10 plus 4 is 14. So 14 by root 14. So root 14 is the radius, right? I can write 14 as root 14, root 14. So one root 14 will get cancelled. So radius is root 14. So equation of sphere is x minus 1 whole square, y minus 2 whole square, z minus 3 whole square is r square. So r square will be 14. So this is the equation of sphere. Now we need to find the radius of circle which is cut by the plane. Okay, so we have one more circle, and this circle is formed by a plane, right? By a plane, and this circle is formed by this plane, right? Now we need to find the radius of this circle. We need to find the radius of this circle. So let us say this is the center of circle. Now this is the radius of circle. Let this capital R be radius of sphere. So capital R is okay. Let us take this as capital R. So capital R is radius of sphere, which is root 14. Now what is P? So this distance is P. This distance is P, right? So P is the perpendicular distance from that point to the plane. So this plane is x plus y plus z is equal to 0. This means we will have x1 plus y1 plus z1 divided by root 3. So here x1, y1, z1 is this point. So 2 root 3 is the perpendicular distance, and we know p square plus r square is p square plus small r square, capital R square. So small r square is capital R square minus p square. This is root 14 whole square minus 2 root 3 whole square. So root 2 is the radius of circle. Is it clear? Right only, right? Any mistake I have made? Okay, I think this is correct answer. Not, you check it once again, right? But this is the procedure. If there is some mistake, and check it out. We'll have x1 plus y1 plus z1. Yes, so we'll move on to next problem. First part is very easy. Second part is slightly tricky. Right? So we need to prove that the plane cuts the sphere in a circle of radius unity. That is very easy to prove, right? You can use Pythagoras theorem to prove radius is 1 for that circle. Find the equation of sphere which has this circle for one of its great circle. So first we need to understand what is meant by great circle. So very easy. So what is great circle? See, this is a sphere, right? So inside this we can form many circles, right? These are many circles we can form like this, right? Many circles we can form like this. So among this, a circle with the greatest diameter, that is called great circle, right? Uh, so inside this, a circle with the greatest diameter. That means a circle whose radius is same as the radius of sphere. This is called great circle. And these two are called small circles, but we don't know this concept at this moment. There will be two small circle, but there will be only one great circle. So a circle with greatest diameter inside the sphere, right? This is called great circle. Okay. So I don't want to write this, right? So great circle means a circle with greatest diameter inside the sphere. That is called great circle. Okay. So now we will do this. Okay. So we need to first we will prove the first part, right? First part is very easy to prove. So prove that the plane cuts the sphere in a circle of radius unity. So this C1 is the center of circle. Capital C is the center of sphere. This P, this capital R, this small r. So we need to show small r is 1, right? This is the first part. To prove that the plane cuts the sphere in a circle of radius unity. Okay, so first we will find capital R and P. Both are very easy to find. So capital R is nothing but radius of sphere, uh, and capital P is the perpendicular distance. First we will find x square plus y square plus z square minus x plus z minus 2 is 0. So 2u is minus 1, 2v is 0, 2w is 1, v is minus 2. So u is minus 2, v is 0, w is 1 by 2, d is minus 2. So therefore, center is minus u minus v minus w. So 1 by 2, 0 minus 1 by 2 is the center, and the radius is root of u square plus v square plus w square minus d, root of u square plus v square plus w square minus d, plus 2. 2 by 4 is 1 by 2 plus 2. So root 5 by 2 is the radius of sphere. So this is root 5 by 2. Now we'll find P. P is the perpendicular distance from the center to the plane. So plane is x1 plus 2y1 minus z1 minus 4 divided by root of 1 plus 4 plus 1. So here x1, y1, z1 is the center, which is minus 1 by 2, 0, 1 by 2. So minus 1 by 2 minus 1 by 2 is minus 2 by 2. So minus 2 by 2 is minus 1. Minus 1 minus 4 is minus 5. Minus 5 by root 6. This is 5 by root 6. So you will have p square plus r square is capital R square. So p square is 25 by 6. Capital R square is 5 by 2. Or this is plus 1 by 2. X1 is 1 by 2, 0 minus 3, 0. So you have 4 by root 6. I think I made some mistake anywhere. What is center? Okay, okay. I think here we have made mistake, right? Minus z1. So minus z1 will be, so here x1, y1, z1 is 1 by 2, 0, minus 1 by 2. So this will be plus 1 by 2. Now this will be 3 by root 6. So we have proved that the radius is 1, right? So we have proved the first part. Second part is very, very important. Second part is we need to find the equation of sphere which has circle for one of its great circle. So we need to find one more sphere. That sphere, for that sphere, this circle has to be the great circle. This circle has to be the great circle for that sphere. So we need to find one more sphere or that this has to be, we need to find one more sphere, right? So for that this circle has to be great circle. Now what is the equation of the sphere? Equation of sphere passing through a circle. What is the equation of the sphere? Equation of sphere passing through a circle. It is nothing but s plus lambda p is equal to 0. The required equation of sphere is s plus lambda p is equal to 0. Yes or no? Because equation of sphere passing through a circle. We already in the beginning of the class I have recalled you, right? So it is s plus lambda p is equal to 0. So if I find lambda, problem will be done. So how to find lambda? So very important. See, if you understand the single concept, if how to find a sphere for which this circle has to be a great circle. Very simple. Only one idea. So this equation is s plus lambda p. So if I find lambda, problem will be over. So first, what is s plus lambda p? S is there. Okay. Let us uh, equation of sphere. Uh, Let us rephrase this. For which that circle is a great circle. That is given by this. So what is s plus lambda p? S is x square, y square, z square minus x plus z. Lambda times plane is x plus 2y minus z. So if I find lambda, problem will be over. How to find lambda? See, this is same as x square plus y square plus z square. If I take x outside, we will have minus 1 plus lambda x, right? And if I take y outside, we will have 2 lambda into y. And if I take z outside, we will have 1 minus lambda into z. And constant term is minus 2 minus 4 lambda is equal to 0. This is the equation of sphere which we need to find. But we haven't used the condition that this has to be the great circle, right? Okay. Now, what is the center of the sphere? What is center of the sphere? Now, what is center of the sphere? So we have 2u is equal to minus 1 plus lambda, 2v to be equal to 2 lambda, 2w to be equal to 1 minus lambda, right? So 2ux, 2vy, 2wz. So that means u is lambda minus 1 by 2, v is lambda, w is 1 minus lambda by 2. See, this is same for all the problems. Now, to find lambda, this C1 has to lie for C1, sorry, for this circle has to be a great circle, C1 has to lie in this plane. Then we know that for a great circle, radius of that great circle is same as radius of that sphere, right? So for this has to be a great circle. This C1 has to lie in this plane. Yes or no? See, this center has to, actually this is not center. Center is minus, center has to lie in center minus u minus v minus w should lie in the plane. So this is the only idea. To find the equation, this is the equation of sphere you need to find. To find lambda, what you have to do is find the center of this. You say that the center has to lie in this plane, then only it will be a great circle, right? Should lie in the plane x plus 2y minus 4z, x plus 2y minus z minus 4 is equal to 0. Now what is center? Center is minus minus of lambda minus 1 by 2 minus lambda minus of 1 minus lambda by 2. This is the center. Now substitute this in the plane, right? Substitute this in the plane. X plus 2y minus z minus 4 is equal to 0. So substitute this point here, find the value of lambda. Right? After finding lambda, substitute this lambda here. That is the equation of sphere for which this circle is a great circle. So only idea is you just write s plus lambda p is a required equation. Find the center using the formula minus u minus v minus w and make use of the condition that the center has to lie in the plane. Find the value of lambda and substitute back here. So you will get lambda to be equal to minus 1, right? So therefore the required equation is s plus lambda p is equal to 0. So s minus p is equal to 0. So you know s, you know p, just subtract this, right? Or you can also put lambda to be minus 1 here. So x square, y square, z square. If you put minus 1 here, you will have, if you put lambda to be minus 1 here, you will have minus 2x minus 2y minus 1. 1 minus half minus 1 will be plus 1, so it will be 0. So if you put minus 1 here, minus 2 plus 4. This is the required equation of sphere for which that circle is a great circle. Is it clear? A very easy problem, very important problem. They will ask you to find a new sphere for which that circle is a great circle. That means equation is s plus lambda p. So to find lambda, make use of that conditions. Okay, we will do two more similar problem based on this. I'm not going to do this. We're just going to take this exercise. So two more similar problems. These great circle problems are very important. Same problem. Find the equation of sphere for which this circle has to be great circle. So they have given and the equation of sphere. Okay. So they have given a circle. So whenever they have given a circle, you just think it of it is a section of a sphere and a plane. Right? So they are given S, they are given E. Okay, so first what we need to find is we need to find an equation of sphere for which this has to be a great circle. So we need to find a green circle, green sphere, right? For this has to be a great circle. Okay. So what is the equation of the required sphere? Before that, we will have some. Will be this is the center of circle. This is center of sphere. This is radius of circle. This is E. This is capital R. So first we need to find the required equation is S plus lambda p is equal to 0, right? So equation of circle passing through a given circle is S plus lambda p is equal to 0. Again, to find only thing is we need to find lambda here, right? The previous question we have two parts. First part is we need to prove radius is 1. After that we need to prove second part. But here we have only one part. So S plus lambda p is 0. So again make use of the condition that center has to lie in this plane for a great circle. So x square plus y square plus z square plus 7y minus 2z plus 2 plus lambda times p. 2x plus 3y plus 4z minus 8 is 0. So we have x square plus y square plus z square 2 lambda into x 7 plus 3 lambda into y minus 2 plus 4 lambda into z 2 minus 8 lambda is equal to 0. What is center? Center is minus u minus v minus w. So we have 2u to be this. So 2u to be, okay, let us write. So we have 2u to be 2 lambda, 2v to be 7 plus 3 lambda, 2w to be minus 2 plus 4 lambda. So u is lambda, v is 7 plus 3 lambda by 2, w is minus 1 plus 2 lambda, right? So take 2 outside and cancel this. So center is minus u minus v minus w. So minus lambda minus 7 minus 3 lambda by 2, 1 minus 2 lambda. This is the center. Now for great circle, center has to lie in this plane. Center has to lie in the plane. What is the center has to lie in this plane? 2x plus 3y plus 4z. Now substitute the center point here. So minus lambda y. Y is 7 minus 7 3 lambda by 2. Z is 1 minus 2 lambda. So minus 2 lambda minus 21 by 2 minus 9 lambda by 2 plus 4 minus 8 lambda minus 8 is equal to 0. This is minus 10 lambda minus 9 lambda by 2. 4 minus 8 is minus 4. So we'll have 4 plus 21 by 2. This is minus 29 lambda by 2. 4 2s are 8. 8 plus 21 is 21 by 2. 2 will get cancelled. So we will have lambda to be equal to minus 1. So when lambda is minus 1, that circle will be a great circle. So we will have the required equation is S plus lambda p is equal to 0. So S minus p is 0. So lambda is minus 1. So x square, y square, z square minus 2x When lambda is minus 1, minus 2x. When lambda is minus 1, 7 minus 3 is 4. So we will have 4y. When lambda is minus 1, minus 2 minus 4 is minus 6. When lambda is minus 1, 2 plus 8. This is the required equation of sphere for which that circle is a great circle. Okay, I think there is some internet connection problem. So my voice is audible, right? So what I have did is I've just put I'm just substituting the center point here, so that you will get lambda to be equal to minus 1 and substitute back lambda value here. You will get the equation of sphere. I'll give you an exercise problem based on the same problem, and then you wind off this session. Take this exercise problem. So just take this as exercise problem. This is the answer you will get, right? So in this class, we have solved some problems based on finding the center and radius of circle and to find the sphere for which that circle is a great circle, right? It is s plus lambda p is 0. To find lambda, make use of the condition that center has to lie in this plane. The next class, we will continue more problems. So thank you. All the best.